if you're in anywhere close to getting this problem, I think you're doing pretty well. I think this is quite a difficult problem. The first part says to find the tangent line at x equals e. So in order to make a tangent line, we first need the slope at that point. So the slope we can get from the derivative, which is y prime equals 1 over x. And I need it at e, so that's 1 over e. And then I need a point as well, and they gave us that. That's nice. So that's e1. So now I can just do y equals mx plus b. Y equals mx plus b, which is 1 equals 1 over e times e plus b. That's 1 equals 1 plus b, so b equals 0. So my y, my equation that we're talking about is y equals 1 over e times x. Okay? We actually could have cheated a little bit and done this. You can see right here they gave you the tangent line. It's right here. The slope is up 1 over e. Up 1 over e. And the y-intercept is 0. So that would have been kind of nice just to cheat a little bit. But I don't know how much credit you would have gotten for that. So the second one, it says show that the derivative of this function with respect to x is ln x. You are not allowed to assume that you know ln x, but you're just taking the derivative of this, and it should be ln x. Okay, so now the hardest thing to remember here is that this is a product rule. So first, derivative of the second, plus the second, derivative of the first, minus the derivative of x, which is 1. So that's 1 minus 1, and we're left with ln x. Part C says that we have this function ln x, and we have our tangent line 1 over e times x. We need this shaded region in here. So the strategy here is to take the area of basically this triangle, and we're going to subtract it from the area of that little curved piece, and then we'll be left with this piece on the inside. So I'm gonna take a little bit of a shortcut here. This is literally a triangle. You do not need integral calculus to find the area of a triangle. Okay, so the width of this triangle is e. The height is 1, and then you take base times height divided by 2. So the area of that triangle is e over 2. Now I just need the area of this curved piece, and I can subtract them. So the area of the curved piece is from 1 to e and let's see here, 1 to e L and ln x dx. Now, you do not know the integral of ln x. It is not in your formula booklet, but the way the IB does this is it did that in part B. If the derivative of this is ln x, that means the integral of ln x is this. That's how they do that. That's a little bit of a trick, but just make sure you pay attention to the previous parts. So that's x ln x minus x from 1 to e. If I plug in e here, we get e ln e is 1 minus e minus, plug in 1, 1, let's see, 1 times 0, ln of 1 is 0. You can see that right there, minus 1. So we're left with, that goes away. Minus, that's 0, that's a plus 1. So I'm left with plus 1. So minus a positive 1. And you see there it is right there.